Good to go?
Yep. How are you?
Hello. Greetings from South Florida. Come up this week. It was great spending time in New York. So my name's Rick Blalock. I'm from Agentuity, one of the co-founders. And by the way, just a shout out with Fonzie. I got a preview of that last week. And I got to say, in my last company, when we had to hire 50 people in a really short amount of time, I would have loved to have that. So check it out. I'm really, really excited about using it as we scale. I'm actually just hoping to get extra minutes in my presentation by, it's like tokens in LLM. Please, a little bit more Claude code. All right, so I got 10 minutes. We're going to fly through this. So I'm going to talk about agent chaos, deploying agents. They can be chaotic. And so what we're going to cover today, some of the headaches. If you haven't tried to deploy an agent yet, an AI agent, we'll talk about some of those. And then we'll talk about what agents need to be successful. That's something we talk about all the time. That's a good way to frame it. And then we'll talk a little bit about what we're doing to try to solve it. I'm going to try to do, it's like a pseudo live demo code thing because it's not my laptop, so we'll see how these videos work. So personal story, a little over a year ago, I was building a project to see if I wanted to start a company, and it was qualitative research. I was a CPO at the time, and one of my number one problems was qualitative insights. And so I built this whole kind of like a type form, Survey Monkey, real easy to send out. I was trying to do qualitative research at quant scale using agents. And so I built this whole thing, coded it out. It was great. We had 15, 20 customers on it. And I started running into problems when I started using the synthesis part of the platform. So it built these agents after all the research came in. It would, in qualitative research, it's called coding, where you highlight certain words and certain tags and stuff. And my agent ran for 45 minutes. Well, guess what? I built the whole thing on serverless, like an idiot. And it didn't work, right? Because timeouts, you can't get 45. So then I'm like, all right, let me re-architect this. I moved this over to ECS. And then I ended up at the end of the day, and this is what happens with agents, you end up at the application layer that we're so used to building on the last 10 years, and you end up kind of going back to 2005, and you're like, I'm on an EC2 instance, or I'm on a VPS. You end up you go all the way down the stack, and you're like, I'm just running on a VM now. That's what happens because of how things are set up. Another good example, so Joel's back there. Joel, raise your hand. He's a University of Florida student, go Gators. And I was speaking at University of Florida last year, and same thing, I was talking to some graduate students, and all of their projects were agentic type projects, even one of the professors I was talking to. Same thing, they built it on serverless, didn't work. 80-90% of their time was spent on their project was spent dealing with infrastructure. Pain in the butt. So, there's that. Then there's the whole, then you got to get multiple agents in and they got to talk. And what if this one needs to scale different than that one? So there's a lot of that you run into if you haven't deployed an agent yet. These are the things that you have to think about, especially if you're used to serverless as a full stack dev. We're all kind of used to, reaching for Vercel, reaching for AWS Lambda, whatever. And the other thing is with agents, it's different. We're so, if you've been a full stack developer for any amount of time, we're so used to thinking in stateless systems. And that's not what an agent is. An agent is stateful. So that's a headache. So one of the things that we do to try to frame this, what does an agent need to be successful? An agent is a persona, is how we think about it. So one of the things that it needs to run for as long as it needs to run. 2 hours, 30 seconds, 5 seconds, doesn't matter. And it needs to resume quick. A lot of people are doing resumability. I've seen where they just, the agent will spin down and then they'll save it off to a database. And then when the agent spins up, they'll hydrate it again. And we think that's very inefficient. There's a much better way to do that. You can snapshot it. Storage is cheap. We've got some things that we're doing with that. The other one is many inputs and outputs. So it's not intuitive if you haven't started building these use cases yet, but an agent isn't just a REST API that you talk to. It needs an email address. It needs a phone number. You end up once you start building use cases out, we have a government customer, and they have this legacy on-premise system, and guess what? They don't have webhooks. They don't have a way to trigger things. So guess what we did? We gave the agent an email address, and now it's just like a person. So that's how we trigger these things. So they have different inputs and outputs. It's not just REST. It's not just webhooks. The other thing is introspection, observing these things once they get deployed, it's kind of a black box. It is very much a black box. And I put up here self-observability and self-reflection because this is something that they need to do. We have agents that, you'll see on a technical level, you'll see things called LLM as a judge and different agentic patterns. And they're just, I kind of lump them in as self-reflection, self-observability. They have to be able to see what they're doing, and if it's wrong, they have to know that it's wrong. And over again. And then I won't go through all these, but the other one is coordination with other agents and humans. So somebody said this on X recently. If it was one of you, I'm sorry, I can't remember who said it, but I totally agree with it. If you frame building an agent for your use case as it's just going to do everything for us, then you're in a world of pain. You'll be disappointed, at least right now. Maybe in 3 months, or maybe Thursday when OpenAI does their next announcement. I don't know. But right now, you'll be a little disappointed. But if you frame it where the human, we are at the beginning and we're at the end, and then all the stuff in the middle it kind of takes care of, actually, you'll get a lot of success that way. And actually, honestly, if anybody's used Claude Code or Ant Code or Cursor, you know that's true. Because you start it, and then you kind of verify at the end. And we've seen that with business customers as well. You get much more success when when humans are in the loop. Or maybe agents are saying, we get much more success if humans are in the loop. So anyway, just a couple things on what we think agent needs to be successful. There's a few other things. Now I'm going to try to speed through a demo of what we're building. So remember I went back to my personal story and the story of UF. Like, there's a problem with deploying and running agents. So that's the first product of our cloud infrastructure that we built. I just want to talk through that really quick if I have time. So I'm just going to talk about the developer experience. So we have a CLI, and it's really easy just to run Agentuity create, and it'll spin up an agent project. You can pick your organization. And the one thing that's important here is we support 3 runtimes, Bun, Node, Python. Notice we put UV up there. Please don't use pip, use UV. If you're a Python person, you know, right? Anyway, we have 3 runtimes that are specialized for deploying. Like, these things will spin up in 100 milliseconds. Well, Bun will. Python, But then after you pick your runtime, one important thing is, you're going to see here in a minute, there's templates. So we are framework agnostic. We are not a framework. And then the reason is we even have internally, actually when Joel started with us and Nick, they were doing everything in Python. And we have internally Python agents, JavaScript agents. And if you're in a big org, you might have somebody's building something Crew AI, LangChain over here, Vercel AI SDK over here. And so we're agnostic to that. What we want to do is we want to solve the infrastructure problem, not the framework problem. We think that your Vercel AI SDK team, their agent should be able to talk to LangChain in the same medium without any kind of special proprietary stuff. So that's how we approach it. Anyway, so there's that. Once you pick your template, how are we doing on time, Drew? Am I doing good? Yeah? Okay. He's laughing at me. So there's a project, which is a grouping of agents, and then you create an agent. You can put multiple agents in a project. But the authentication is important here because, again, back to like it's a pain in the butt to wire up a bunch of agents to talk to each other and these cloud providers. It's really hard. It's a pain. So we make it really easy. And if it's in your project or in your org, then it's agent-to-agent communication that doesn't go outside the internet. But you can also create an endpoint or webhook or an SMS or whatever, and that goes through the internet. And so that you can secure all that automatically. And then I'll just skip through some of these things real quick to be fast here. You can also hook it up to your GitHub app. So then you merge the domain, and then it just automatically deploys. I'm trying to get through here. And then once it's deployed, I'm going to skip through some of this stuff because I'm trying to save on time so we have questions. Then we give you a really good dev experience with a simulator. Again, this is the other problem with building agents is how do you get it to work? How do you get to work with multimodal, with different types of inputs, outputs, SMS? And you can do all this in this agent simulator, which is local. And then, of course, you get, I'll just fast forward through this. You get, once you run it, you get tracing, OTel logging, and costs and that kind of thing. And code-wise, just really quick, we don't have that many conventions. It's kind of up to you, really. We have a YAML file just to specify a couple things, and then the agent is really just a function handler. And anything, whether it's coming from the internet or internally, internal DNS, internal writing, it all happens through this function handler, and then we give you things like vector store, KV, all out of the box without having to set up anything. You don't even have to set up, like in this case, I'm using Grok with a Q, most unfortunate name ever. Grok with a Q, you don't even have to set up an account. We have an AI gateway, so then you can prototype stuff really fast without setting up 30 accounts to 30 different AI providers. And then after that, it gets deployed, which I won't run through, so I'm trying to save time. And then once it's deployed, you'll see it in this deployment type thing, which should be familiar with a bunch of us that are used to building full stack web apps. And then here is where decoupled from your code, you can give it an email, you can give it an SMS. And that's pretty much it. So that's how we're trying to solve my original problem from a year ago, which is, what do agents need? And we like to say it's serverless without the downsides.
Everyone, thank you for coming. My name is Ben Lerner. I am one of the co-founders of Espresso AI, and I'm going to be talking about faster, cheaper data warehousing with AI-enabled scheduling. Different way to phrase this is Kubernetes for Snowflake, which might be equally confusing. Espresso AI uses ML to automatically optimize compute. We're starting with data warehousing, and we're starting more specifically with Snowflake. By show of hands, how many people have used Snowflake before? Cool, quite a bit of the room. How many people are using Snowflake at a job today? Okay, you should all email me. I used to work on performance engineering and machine learning at Google before this. We save people money on Snowflake. We effectively structure this in machine learning world as a constrained optimization problem. So at any given time, actually, I guess for people who aren't familiar with Snowflake or with data warehousing, a data warehouse is effectively a really large cloud scalable database. So back in the day, you used to have a Postgres cluster, and if your analysts wanted to run something complicated, they would, and it would freeze up your site, and then someone would come yell at them, and then they would have to stop doing what they're doing. And so to fix this, you can now run things on the cloud, and the cloud will just auto-scale. And you've changed your problem from people freezing your site and being angry at your analysts to you now use this thing that can scale, but can also burn $100 bills as fast as you can insert them. And so people have their jobs running here kind of, all the time, there's stuff coming in. And our job is to take those existing workloads and reroute them and run them as cheaply as we can without increasing latency. We do query optimization, we do auto-scaling, and we do scheduling. Scheduling is what I'm talking about because this is a 10-minute talk. So scheduling is the idea of taking workloads that come in and physically allocating them across clusters. Again, if you're familiar with Kubernetes, it's the same concept, but basically rather than running an agent on a specific EC2 box or SQL query or whatever, you have a pool of compute and you have some sort of intelligent scheduler that actually can effectively go and run it. Big data centers do this with Borg and Kubernetes. Most people don't like Kubernetes. I actually only know about Borg, and I have much warmer feelings towards this whole idea than if you've had to deal with Kubernetes. This can be hugely impactful. So very common to have utilization of 40 to 60% in a data warehouse. So half your machines are idle. 20 to 50% is not uncommon for all my stuff is running on EC2 and I hard-coded all of the machines. With something like Kubernetes, 80-90% is doable. And so if you look at our site, it says we'll save you up to 70% on Snowflake. That's a real number, and this is how we do it. Today, Snowflake basically doesn't do scheduling, or does it statically. People will just have sort of, here's my cluster for ETL, here's my cluster for BI, here's where finance is running their workloads. And if you have an ETL job come in, it will spin up the ETL cluster even if there's a bunch of available hardware already. Sometimes it'll spin up clusters and you don't even need them. It's just kind of anticipating a spike that's not coming. So all of these sort of bad patterns lead to having really bad utilization. These slides didn't use the tab line by line, so I don't know which line it ends on is as much a mystery to me as it is to you. You can do better scheduling by predicting how queries run and how they scale, right? So the way that Kubernetes works is you hand annotate jobs. You say, I need 2 cores and 3 gigs of RAM and some amount of bandwidth. When you send a SQL query to a data warehouse, we don't really have that information. And so to make up for that, we trained a bunch of models that can take in the SQL text and actually say, this will run on this cluster in 4 seconds or 10 minutes or an hour or whatever it is, and that's what enables us to route things. There's 3 core components. There's resource requirements, like I said, which is effectively how long is this going to take to run on this compute. There's resource availability. Is this cluster full? Can it run this? Is this going to increase the runtime of everything already on the cluster? And then there's an algorithm for, okay, what is the optimal placement here? We're an AI company, so we just use AI for everything. So when you have a hammer, everything looks like a nail. AI is great, actually. It works really, really well. That's actually why we do it, but that's less funny. Went through this. Scheduling algorithms are a really fun area of research. Bin packing this is largely a technical audience, so people are probably familiar. Bin packing is a very classical area of study. Greedy algorithms work well, especially when you're going from doing nothing to doing something. There's a lot of more efficient stuff you can do. Some of it is really difficult and NP complete. Some of it is just a simple, hey, this job spikes every time. We should probably predict that it's going to spike. Now, it's the 400th time you're running it. We've seen this pattern before. But overall, the best bet is probably end-to-end reinforcement learning because especially at scale, all of this stuff is just really, really complicated. You want to understand what's going on, when things are ending, how things scale, what might be coming down the pipeline. It's probably too complex to do by hand or with heuristics. Some other things that RL can learn. Taking queries and running them on a larger warehouse because there's some capacity and idle time that you're not using, so stuff can actually come back faster. Understanding end-to-end job latency. If I'm going to not get much of a speed up, because parts of so you can think of the DAG of a job, right? And there's stuff that's not in the critical path. So maybe you can offload all of that, and it's okay to actually run that slower because there's no end user impact. Queuing jobs, right? Maybe I can, I have an hour-long job and I can save 30 seconds of runtime where I wouldn't have anything else running by queuing it for a minute, and pushing it from 60 minutes to 61 minutes is not that important, but you can sort of start driving costs down. Here's an example. So this is a really basic example of what our product looks like in practice, right? dbt, which is a super popular ETL tool, might be running on one warehouse, Looker might be on another, and you have someone sending in queries through the web browser. Spinning up 3 different machines, all of which are underutilized, which is very common, and totaling 3 credits. A credit is like $1, or usually $2 or $3. If you route everything more intelligently, maybe you can fit them all on one warehouse, and nothing takes any longer to run, and you've just saved half your bill. Obviously, a relatively simple, contrived example. Here's what a real one looks like. So this is a Sankey diagram. It's real-life routing from a beta run with an early customer, and you can sort of see basically here all the savings come from taking this big cluster and opportunistically putting this on other smaller clusters that have a bunch of idle time. This had, I think, 20 or 30% savings, something along those lines, maybe more.
Hi, my name is Claire. I work at Google DeepMind on the Gemini app. So this is a chat interface for users to ask anything from simple queries to interview prep help, coding queries, relationship advice, you name it. So one of the projects that I worked on launched back in March, and it's called Gemini Canvas. So I'll be talking about that today. Before I do that, I'll do a little intro about me. So like I said, I'm a software engineer on Gemini. I focus on the modeling and designing these systems to make the chat interface a more assistant-like experience, really helpful and resourceful. Before this, I was an AI engineer at Square. I worked on the conversations team, mainly helping customers or businesses talk to their customers more effectively, working on things like suggested replies and making them more personalized with Brag. And before that, I was in school. I did my master's on how to incorporate common sense knowledge into language models. So enough about me. Now I will do not really a deep dive, more of a shallow dive of Canvas. So first I'll talk about what exactly it is and why we decided to build it. And then I'll talk about how we built it. So everything from the post training to prompt tuning to our evaluation framework. And then I wanted to touch a little bit on how Canvas sort of ties into the future of these agentic and interactive experiences and sort of what we've learned over the past 6 months since the launch. So Canvas sort of brings the Gemini experience beyond just the chat interface and creates this interactive workspace where users can collaborate with Gemini. So here's a little video. Figured visuals are always better. It's definitely a more marketing-esque video, but hopefully it's helpful. Basically, the user can input a query and Gemini then generates either code or text in this canvas. For code specifically, there's a preview button, so the user can see exactly what they're building. If it's a game, they can play it live, they can iterate on it with the model. If it's a web app, they can see what it would look like without having to export it to their IDE. So the main problem that we're trying to tackle is this idea of context switching. We find that for really complex problems, whether it's with code or text, there's a lot of conversation history. We get in these like really deep multi-turn conversations, and it makes it really hard for both the user and the model to focus on what they're iterating on. So Canvas allows users and the model to both focus on whatever's at hand. So the user can express this query to the model to generate either a code or a text canvas. They can instantly preview the code that they're writing without having to export it. And then they can continue to collaborate with Gemini. We have a bunch of features like select and ask. The user can select a piece of the code and ask specific questions to Gemini or ask the model to edit that specific part of the code. They can also the model can suggest edits for the user or the model itself to make. And then when this is all done, the user can export it and share it with the world. I don't know what this slide is. So the idea behind Canvas, again, is to exploit these powerful models beyond just the first turn generation of code and text documents. We have really powerful models that can do really cool things, and we don't want it to get lost in the conversation history. There's also this concept of vibe coding that's become really big. I'm sure we're all using it. And I think Canvas is a great platform where users can learn to vibe code and they can exploit the model capabilities. So they can come up with an idea and just work with the model really closely in a really focused manner to build something really cool and share it. But we started with the base Gemini model, which is really powerful, but it's not really trained to build these really cool artifacts on the first generation, not necessarily complete code. So the challenge that we faced was, okay, we have a model that knows a lot, but how do we get it to do exactly what we want? We want it to build these really complex, creative web apps that look really visually appealing. To tackle this, we did a lot of post-training. So first, we have supervised fine-tuning of the model, or SFT. So this is labeled data pairs of user prompts and model responses of really high-quality code. So we had to make sure, this data was really well curated because we're feeding it directly into our model. But the problem with this is it's not super scalable. You have to go through every single piece of the data, and if you want to change one thing, you have to change it across all the data. And sometimes you lose track of your data. So this is where RL comes in. RL is much more scalable because all you need is some reward mechanism. So like high code quality or like very visually appealing code, and some set of user prompts, and then you can just you can train your model on that. And finally, we have prompt tuning. So with these more powerful models, we're also seeing that they're really good at taking in natural language instructions from users. So for things that are more generalizable, like, oh, Gemini, don't generate incomplete code or generate really understandable or well-documented code, we can get there with just prompt tuning. So the entire approach is sort of finding this balance between what needs SFT, where RL can come in, what rewards to use, and where we can just rely on prompt tuning that is definitely the most scalable and the easiest to iterate upon. So now that we have the teaching the model the vibe part, how do we check if we taught the model correctly? So we need to vibe check the model. So I'll talk a little bit about our eval framework and how we built it. So first and most important is human evals. Given how much variability there is in both code and text generation, human evals are like the least noisy, and you can really rely on them when you're releasing a new model in production. So we made sure to define our metrics very well and have very high coverage across different types of user journeys and also different features that we have on campus. But the thing with human evals is it's very time consuming, it takes a lot of resources, so it's not really ideal for experimentation, and this is where LLM-based evals come in. We can sort of use the same metrics that we defined before, use even larger scale of data sets to more quickly iterate upon features we're adding or user journeys we're adding, etc. If we want to tweak the prompt a little bit, we do this several times a day, then these become very useful. And another thing I wanted to touch on is I talked a lot about improving code quality, but when you put in a lot of work, post-training and prompt tuning for a specific task, you make the model vulnerable to regressing in quality on other tasks, right? So while we're evaluating the code quality, we also need to make sure the inherent model behavior is intact and it's still generating text properly, it's still instruction following properly, it's not hallucinating. And another thing is I mentioned how code and text can be very variable and very noisy. So single-sided evals are helpful somewhat, but side-by-side evals, comparing a baseline and an experimental model become really useful and sort of denoise the process. So we launched back in March, and since then there have been a lot of new models released that are very powerful. We see Gemini 2.5 Pro, very good at coding, very good at reasoning, text, math. And we found that a lot of the post-training we did was no longer necessary. So we could alleviate a little bit of that and move a little bit more towards prompt tuning. And I think this is a trend that we'll continue to see. These models are getting even more powerful. And we're also seeing, so we need to adapt to these new models in a really fast manner. And be very thorough about it, right? We need robust eval systems to make sure that this new model isn't breaking our system. And we see the future is very agentic. Like, we see all these startups, we see everyone building agents, and this requires a lot of either agents doing things in a very narrow scope or at a very wide scope, but either way, we see a lot more context too. So things like Canvas, where it's a lot more interactive, will be very useful in the future. And we just need to keep adapting, right? We don't want to continue updating our post-training process based on these constantly changing models, and we need to make sure our evals are continuing to be flexible with whatever these new releases are. Thank you.